Welcome to the course Business Analytics and Data Mining Modeling using R. This is the very first lecture and we are going to cover the introduction part of it. First we need to understand why we need to study this course. If you follow the industry news and related reports, you would see that there is a huge requirement of data scientists, data engineers, business analysts and other positions, other relevant positions which require expertise in domains like business analytics, data mining, R and other related areas. So, we are going to cover some of these things in this course. So, let us start. So, what is business analytics? The primary purpose of business analytics is to assist and aid in and drive in decision making activities of a business or organization. Now, if we look at the Gartner's definition, they have defined business analytics as comprised of solutions used to build analysis, models and simulations to create scenarios, to understand realities and predict future sales. The domains which are actually part of business analytics are data mining, predictive analytics, applied analytics, statistics, and generally the solution is delivered in an application format which is suitable for business user. Now, if we look at analytics as such, it can be classified as three categories: descriptive analytics, predictive analytics and prescriptive analytics. Now, let us first understand descriptive analytics. Descriptive analytics mainly revolves around gathering, organizing, tabulating, presenting and depicting data and describing the characteristics of what you are studying. This is about descriptive analytics is mainly about what is happening. So, we try to answer the question what is happening in a particular context looking at the data. Now, this is also called reporting and managerial lingo, reason being because we generally look at the sales number, cost numbers, revenues number, etc., different ratios. So, there we try to understand how a business is performing, how the company or organization is performing, or how the industry or country's economy is growing in an overall sense. So, therefore, what is happening actually is covered under this descriptive analytics. This is also first phase of analytics. This is where you actually start. You try to gather the sense of what is happening and then you look for other things, other categories of analytics. Now, this descriptive analytics can be useful in the sense to inform why the results are happening, but they do not inform why the results happen or what can happen in future. To answer these questions, we need next phase of analytics, which is predictive analytics. So, predictive analytics can be defined as predictive analytics mainly use the past to predict the future. Now, the main idea is to identify association among different variables and predict the likelihood of a phenomena occurring on the basis of those relationships. Now, at this point we need to understand the concept of correlation versus causation. Now, correlation is something if something is happening, if X is happening, if X is correlated with Y, that is sufficient for us to predict something. But if we are looking for what we should be doing about it, if we know that what is going to happen in the future, which is going to be part of predictive analytics, then what we are going to do about it is becomes part of prescriptive analytics. Now, prescriptive analytics is where the cause and effect relationship that comes into effect, and the main idea of prescriptive analytics is to suggest a course of action. So, generally prescriptive analytics is about recommending decisions, and which entails generally in mathematical and computational model you do lots of simulations, optimization to find out what can be done about the future scenario of the business or relevant topic. So, prescriptive analytics is also defined as final phase of analytics. Now, methods from disciplines like statistics, forecasting, data mining, experimental design, they are used in business analytics. Now, next part, that brings us to the next part, data mining. The core of this particular course is data mining. So, let us understand what is data mining. A brief definition of data mining could be extracting useful information from large data sets. Now, if we look at the how Gartner is defining data mining, so they define data mining as the process of discovering meaningful correlations, patterns and trends by sifting through large amount of data stored in repositories. Now, data mining generally it employs pattern recognition technology as well as statistical and mathematical technique. Now, where is data mining used? What are the domains where data mining can actually be used? If we look at some of the examples given here, first one is related to the medical field. So, data mining can actually help us in predicting the response of a drug or a medical treatment on the patient suffering from a serious disease or illness. Another example could be in the security domain, where data mining can help us predicting whether an intercepted communication is about a potential terror attack. Now, another application of data mining could be in computer or network security field, where it can help us predicting whether a packet of network data can pose a cyber security threat. Now, our main interest is in the business domain. So, let us look at some of the examples where data mining can help in business context. So, common business questions where data mining can help it could be like this. Which customers are most likely to respond to the marketing or promotional offer? Another example could be which customers are most likely to default on loan. So, banking and financial institutions, they might be worried about some of their customers defaulting on loan. So, they would like to identify such customers and then take appropriate actions. Now, another question could be which customers are most likely to subscribe to a magazine. So, for a magazine, if they are running a advertising and marketing promotional offer, it would be important for them to understand the customer which are likely to subscribe to the kind of content that they are publishing or selling through their magazine. So, all these are some of the flavor of kind of questions where data mining can actually help us. Now, let us look at the origins of data mining. So, data mining genesis, it is mainly an interdisciplinary field of computer science and it originates from the fields of machine learning and statistics. Now, some researchers have also defined data mining as statistics at scale and speed. Some people also define it as statistics at scale, speed and simplicity. Main reason being that in data mining we generally do not use the concepts of confidence interval, logic of inference, rather we rely on partitioning and using different samples to test our models. So, that makes the whole process simpler. So, that is why this simplicity comes from. Now, let us compare the classical statistical setting and data mining paradigm. Now, classical statistical setting is mainly about data scarcity and computational difficulty. So, generally in a statistical setting you are dealing with a statistical question where you are looking for primary data and that is of course costly to collect. So, there is always you are going to face this situation where data is not enough or it is very difficult to get the data. And if we look at the times when statistical it's an old discipline. So, the time when statistical studies they used to face, there was a time when they used to face lot of computational difficulty, because most of the mathematical computation they have to be performed manually. So, that was a time when the statistical setting originated. So, they generally face classical statistical setting is generally they face the data problem, the data scarcity problem and the computational problem. When we look at the data mining paradigm, it mainly it is relatively a newer area and this has mainly developed or evolved because of the availability of large data set and ever improving computing powers. So therefore, in data mining paradigm, we are not faced with the problem of data sets or the computational problems. Now let's look at the another point. Same sample in classical statistical setting, same sample is used to compute an estimate and to check its reliability. While if we look at the data mining paradigm, because we don't have any problem in terms of data points or data sets, therefore we can fit a model with one sample and then evaluate the performance of the model with another sample. So that is another difference. Now third one is the logic of inference. Now we need confidence intervals and hypothesis test to actually because we are using the same sample to compute the estimate and then check its reliability. Therefore, we need to eliminate this option where a pattern or relationship can develop, can be seen because of a chance. So chance variation has to be eliminated. So therefore, a logic of inference is important to the statistical setting, and much stricter conditions are actually placed in a statistical modeling. When we look at the data mining modeling, we don't face with the problems of inference and related problems, reason being that different samples are being used. So therefore, reliability or robustness of the model is automatically taken care of because the model is built on one sample and it is evaluated on the different sample, different partition. If we look at the machine learning techniques such as trees, neural networks, they are also less structured but more computationally intensive in comparison to statistical techniques. So therefore, they might require more running time, more computation time, and they are less structured. While we look at the statistical technique, regression and logistic regression, discriminant analysis, they are highly structured techniques. Now another important aspect of emergence of this field, business analytics, data mining, big data and related fields, is rapid growth of data. Nowadays millions of transactions are recorded on a daily basis. We have organized retailers such as Shoppers Stop, Big Bazaar, Pantaloons, where on a daily basis lots of transactions are being recorded. We also have e-commerce retailers like Flipkart, Amazon, Snapdeal. So all these organizations have huge amount of data because of the transactions which are being recorded. Our economy has also been growing. There has been growth in the internet infrastructure that has also led to many people using internet and digital technologies. So that has also led to growth of data. Automatic data capture mechanisms, for example barcode, POS devices, clickstream data, GPS data, that is also has led to rapid growth of data. Now operational databases, the ones we talked about, whenever you visit a retail stores or whatever items that you want to buy, all those data there can be considered transactions between the business and the customers. All those days transactions are recorded in the operational database. Now for the data analytics purposes or business analytics purposes, these operational database, they have to now brought into a data warehouse, because you cannot actually do any kind of meaningful analysis on operational databases. So therefore the data has to be brought into data warehouse and data marts, from where the data can then be sampled out for the analysis. Now another reason for rapid growth of data is constant declining cost of data storage and improving processing capabilities. So that has also even a smaller organization can nowadays invest in related IT infrastructure and have the analytical capabilities and develop analytical capabilities to improve their business. Now core of this course focuses on predictive analytics. Mainly we focus on three tasks: prediction, classification and association rules. Prediction is mainly when we are trying to predict value of a variable. We'll discuss in detail different terminology and concepts later in this lecture. Classification is a task wherein we are trying to predict type of a particular variable. Association rules is where we are trying to find out the association between different items in a transactions. Now, another important thing related to data mining is data mining and data mining process as such is we generally try different several methods for a particular goal, and then a useful method is finally selected and then used in the production systems. Now, how do we define usefulness of a method? Now, the methods that we select to perform a particular task, of course, they have to be relevant with respect to goal of the analysis. Underlying assumptions of the method they also have to be they should also meet the requirement of the goal and the problem. Size of the data set, different methods and algorithms, they are going to impose their own restrictions on number of variables and the number of records that are going to be used for analysis. So, size of the data set is also going to determine types of pattern in the data set. So, different methods or algorithm, they are suitable for finding out or understanding different types of pattern. So, therefore, type of pattern in a data set is also going to determine the usefulness of a method with respect to a particular goal. Let us look at an example to develop a better understanding. Now, we have this hypothetical example, sedan car owner. So, wherein main goal is income level and household area is used to classify whether a household owns a sedan car. So, we have these two variables, income level and household area, and we are trying to classify. So, this is essentially a classification problem, and we want to classify whether a particular household owns a sedan car or not. Now, let us understand the data set format that is typically used in data mining and business analytics. Now, generally the data that we use is in tabular or matrix format. Variables are generally in columns and observations are in rows. Now, another important thing is each row represents a household, which is a unit of analysis. For example, in this case, the sedan car data set case, unit of analysis is household. So, all the data, all the variables that are there in the data set, they are about this particular household. So, household being the unit of analysis. Now, the statistical software or data mining software that we are going to use in this course is R and R Studio. So, R, what is R? R is a programming language and software environment for statistical computing and graphics, widely used by statisticians across the world and also by data miners. So, there are many packages available for different kinds of functionalities related to statistical techniques and also related to data mining techniques. R Studio is another which is again most commonly used integrated development environment for R. So, it might be difficult for some users to directly start using with R because of the interface. They might not be very much comfortable with the interface of R. R Studio bridges this gap and provides a much better interface to perform your data mining modeling or statistical modeling using R. So, let us look at this example sedan car. So, this is R Studio environment. So, here you have these 4 parts here. First part, this part is about the R script, the code, the R code is actually written here, and this part is actually to run these commands that are given in this script. Then in this part you have environment where all your data and variables they would be loaded up. If a particular data set is loaded into R Studio, it would be shown here. If a particular variable is loaded into R Studio, it would actually be shown here. In this part you have plots, help page. For a detailed so I recommend you to go through the supplementary lecture on introduction to R and basic statistics if you are not able to understand what is going on in this particular case. So, first we need to load this library XLSX because we are using the data set which is available in the Excel format. You would see in this environment window that this data set has been loaded. We have 20 observation of 3 variables. So, here you can look at the tabular data. So, this is the data that we were talking about. You can see that this is in the tabular format or matrix format. So, you have these 3 variables. So, annual income and household area, these are your predictor variables. We will discuss the terminology later in the lecture, and this is your outcome variable ownership. So, we want to predict based on these 2 variables, we want to predict the class of a sedan car, class of a household, whether they own a sedan car or not. If we look at the whole data set, we have 20 observations, and each observation is about a household. It depicts their annual income in rupees lakh, and the household area in 100 square feet. Now, let us go back. Now, the if we run this command headdf, we are going to get first 6 observation from the data set. So, if you do not want to go and actually have a look at the full data set, which might be a large file. So, you might run this command headdf, and then you can look at the first 6 observation of the data set. Summary, this command is going to give you these basic statistics about the data set. Variable, for example, annual income, you can see min, max, mean, and other statistics. Similarly, for household area and ownership. So, you can see from the ownership data, this is a categorical data. We will discuss later in this lecture what is a categorical variable. You can see 10 observation belong to the non-owner category, and 10 observation belong to the owner class. We can also look at the other things. Now, let us plot a graph between household area and annual income. Annual income being on the x axis and household area being on the y axis. So, this is the plot. You can look at if we look at this plot, some of the observation which are belonging to the non-owner category, non-owner class, they are mainly on this part, and the observation belonging to owner, they are mainly on this half. So, our goal is to classify the ownership of a sedan car. Now, as we talked about that different methods could be tried out in a data mining modeling, and then the best one is generally selected. Now, one method in this case could be a set of horizontal and vertical lines. So, we can look at this data and we can create a set of horizontal and vertical lines. This could be a hypothetically method 1, which could then be used to classify these observations. Another method could be a single diagonal line. So, we could draw a single diagonal line somewhere here, and then it could also be used to classify these observations. Now, if we look at this data, if we are able to draw a line somewhere here, most of the observations belonging to owner class, they will be on the upper rectangular region, and the most of the observation belonging to the non-owner class, they would be on the lower rectangular region. So, let us do that. So, if we look at these 2 points, so these 2 points are actually 7.6 and 6. So these are these 2 points. If we look at, if a line can be a horizontal line can be drawn here, then 2 partitions, 2 rectangular regions can actually be created. If we similarly keep on drawing the horizontal and vertical lines to keep on separating these observations, you can see here this particular, only 3 observations belonging to non-owner are there, others are owner observations. In this lower rectangular region, most of the observations are belonging to the non-owner and only 3 belongs to the owner category. Similarly, we can keep on creating similar lines. To further classify. So now finally we will end up with a particular graphic where each rectangular region is homogeneous. That means it contains the observation belonging to only one class, either owner or non-owner. So this could be, these set of horizontal and vertical lines could be a method, could be a model to classify these observations. Similarly, as we talked about, the method 2 could be about finding a single diagonal line to separate these observations. Now, if we look at the again, if we look at the plot again, the line, a diagonal line could be somewhere here, it can go from somewhere here, and then we will have homogeneous partitions, homogeneous rectangular regions. So again, a similar process can be adopted to find out that particular line. You would see a line being drawn there. We can extend this line and create a partition. So this could be a single, this could be another method, method 2, to actually classify the observation. Now, as we as we discuss these 2 methods, method 1 set of horizontal and vertical lines, method 2 a single diagonal line. So now we need to find out which is the most useful method, which is the best method. That can be done using different assessment matrix that we are going to cover in later lectures. Now, let us look at the key terms related to this course. As we go through other lectures, we will come across many more terms and then we will discuss them there. First, we need to discuss the key terms at this point. So, first one is algorithm. So, we have been using this particular term quite often. So, algorithm can be defined as a specific sequence of actions or set of rules that has to be followed to perform a task. Algorithms, they are generally used to implement data mining techniques like trees, neural networks. For example, neural network we use back propagation algorithm, that is part of neural network. So there are a number of algorithms that are actually required to implement these techniques. Next term is model. So what we mean by model? So here by model we mean data mining model. Now how we can define a model in a data mining context? A data mining model is an application of data mining technique on data set. So when we apply some of these techniques like trees and neural networks, which we are going to cover in later lectures, on a data set, then we get a model. Our next term is variable. Variable can be defined as the operationalized way of representing a characteristic of an object, event or phenomenon. Now, a variable can take different values in different situations. Now, there are generally 2 types of variable that we are going to deal with here. Is one is input variable. It is also sometimes called independent variable, feature, field, attribute or predictor. Essentially, input variable is an input to the model. The other type of variable is output variable, which is generally other names for this variable are outcome variable, dependent variable, target variable or response. So output variable is an output to the output of the model. Another term that we will come across, record, observation, case or row. So, as we talked about the tabular data set or matrix data set, each row represented a record, each row represented an observation or case. Now, how do we define it? So, observation is the unit of analysis on which the variable measurements that are in the column are taken, such as a customer, a household, an organization or an industry. For example, in our Sedan car example case, the unit of analysis was a household, and we had the variables like annual income and household area, which actually measure something related to household. Similarly, customer, organization or industry, we could also have these as unit of analysis, and the variables that are measured on these. Now, let us talk about the variables in detail. Now, generally two types of variables are used. So, other types that we talked about, input variable and the output variable or outcome variable, they are in the modeling sense, but here we are talking about more in the data sense. Two types of variables are used, categorical and continuous. Now, categorical variables can be further classified as nominal and ordinal, and continuous can further be classified into two categories, interval and ratio variables. So, let us understand these variables. Now, before we go into the details of what these four types of variable mean, why we need to understand the type of variables in a data set. As we discussed before, that we are in a data mining process, in a data mining modeling, we generally use many methods, and then select the most useful one or the best one. So, therefore, it is important for us to identify an appropriate statistical or data mining technique, and the understanding of variable type is part of this process. Now, proper interpretation of the data analysis results, that also depends on the kind of technique that you are using and the kind of data that was actually analyzed. Now, another important thing is that data of these variable types are either quantitative or qualitative in nature. For example, quantitative data measure numeric values and are expressed in a number. Qualitative data, they measure types and are expressed as label or a numeric code. Now, if we look at these four types, nominal, ordinal, interval and ratio, structure of these variable type increases from nominal to ratio in a hierarchical fashion. So, nominal is least structured variable type, followed by ordinal, followed by interval, and then ratio is the most structured variable type. Now, let us understand nominal variables. Now, nominal values indicate distinct types, for example, gender. So, gender values could be male or female, so they indicate distinct types. Similarly, nationality, again the values could be Indian, Pakistani, Bangladeshi, Sri Lankan. So, all these values indicate they are distinct types. Similarly, religion could be another nominal variable. So, the values will again indicate distinct types, for example, Hindu or Muslim or Christian. Similarly, pin code could be another example for a nominal variable, where each pin code actually indicate a distinct location. Employee ID could be another nominal variable, because each employee ID would actually indicate a different person. Now, the two operations equal to and is not equal to are supported, because these are distinct types. You cannot say male is greater than female, also greater, multiplication, greater than, less than, multiplication, division, all those operations are not supported. Only equal to or is not equal to is supported. Let us look at the ordinal. So, values indicate a natural order of sequence, natural order or sequence. For example, academic grades. So, you have grades like A, B, C, D, E, F. So, they all these grades label, they indicate a order, but essentially they are distinct from each other. Similarly, Likert scales, Likert scale, quality of a food item, they are also examples of ordinal variables. In Likert scale, you come across whenever you are trying to fill a survey questionnaire, trying to reach to the respondents and trying to get their responses, you always get their responses from strongly disagree to strongly agree, or strongly agree to strongly disagree. So, all those points are actually part of Likert scale and can be defined as a ordinal variable. Similarly, quality of a food item, it could be better, it could be average, it could be poor. So that can also be an ordinal variable. Now 4 additional operations are supported because the values indicate a natural order. So therefore these less than or equal to, greater than or equal to operations are also supported. If we look at the continuous variable types, first one interval variable. Now here, apart from what we discussed in nominal and ordinal, difference between two values is also meaningful. Now another important thing about interval variable is values may be in reference to a somewhat arbitrary 0 point. So for example, Celsius temperature, Fahrenheit temperature. So Celsius temperature is generally used in India, where when we talk about the temperature is 35 degrees Celsius, 40 degrees Celsius, and those numbers. Now when we talk about 0 degree Celsius, it's not actually the absolute 0 point, it is rather can be called an arbitrary 0 point. Similarly, location specific variable, for example distance from landmarks, now geographical coordinates, they all are examples of interval variables. Now next, the operations that are supported for interval variables are 2 additional operations. Apart from what we discussed for nominal and ordinal, 2 additional operations are supported, plus and minus, addition and subtraction. Now the last variable type is ratio variable. Now in ratio variables, ratio of 2 values is also meaningful. So values and also values are in reference to an absolute 0 point. Example, Kelvin temperature. So in Kelvin temperature you have 0 degree Kelvin. So when we say 0 degree Kelvin, we actually means it actually means 0 degree 0 temperature, that is 0 in absolute, in real sense. When we talked about the Celsius temperature or Fahrenheit temperature, 0 degree centigrade or 0 degree Fahrenheit, they don't actually mean absolute 0, right, real 0 in the absolute sense. Age, length, weight, height, income, they can also be examples of ratio variables. Apart from the operation that we discussed for nominal, ordinal, interval, 2 additional operations, division and multiplication, are supported for ratio variables. Now another important thing related to variable type is conversion from one variable type to other. Now high structure variable type can always be converted, because we discussed that these variable types, they have hierarchy of a structure. So therefore high structure variable can always be converted into a low structure variable type, but we cannot convert a low structure variable into a high structure variable. For example, a ratio variable age can be converted into an ordinal variable age group. So age group could be like adult, young, old, middle age, but age could also be a specific age could be 20, 21, 25, 40, 45. So this actually being a ratio variable. Now based on these actual numbers, you can actually convert this variable into a ordinal variable, where you say that less than 20 is young, then 20 to 40 it's adult, then later on middle age, and then old age. So that kind of grouping can actually be done. So therefore a high structure variable can always be converted into a low structure variable type. Now let us discuss the roadmap of this particular course. So the module first, which we started in this lecture, is a general overview of data mining and its components, which covers the introductory part and the data mining process. Then the module second is about data preparation and exploration. Here we talked about the different steps that are required to prepare the data, to explore the data, visualize the data, and other techniques like dimension reduction, etc. Now third module is about performance metrics and assessment, where we will try to understand the metrics that are actually used for tasks like to assess the performance of different models for tasks like classification and prediction. Now the next module, fourth module, is about supervised learning methods. There we are going to cover data mining and statistical techniques like regression, logistic regression, neural networks, trees. So those techniques and many others are going to be covered in this particular module. Module 5th is about unsupervised learning methods. There we are going to mainly cover clustering and association rules mining. Then next module is time series forecasting. There we are going to cover the time series handling, regression based forecasting and smoothing methods. Finally, the last module will have some final discussion and concluding remarks. Now, apart from this roadmap, we will also have 2 supplementary lectures. One is on introduction to R, the another one is on basic statistical methods. So, it is highly recommended that you go through these 2 lectures before proceeding further for next lectures. These are some of the key references. Thank you.